Hello, 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 test, hello, hello. Okay, testing, hello, hello, test, hello, hello. Okay, testing, hello, hello, test, hello, hello.
Just see. I'm trying to see if this is working. Hello.
Just see.
I'm trying to see if
Okay,
this is working.
wow.
Hello.
Okay, okay, okay. So, alright, first of all, I apologize that when that last video, I was streaming for like an entire day, and I guess there was inappropriate stuff in there and had to be taken down. But at the end of that last video, I kind of had gotten a little lesson, like a kind of a little lesson plan together and a little like presentation, and so I'm trying to just do a live stream now and just do the thing at the end of that video and just like show you what I was doing. So let's see here. Okay, so first of all, I will begin streaming. My this is yep. I'm just like yet another streamer on the internet. Womp womp. Okay, so now we'll go over here to the lesson plan. This is where the lesson plan is. So, and I was showing you guys this robot mostly. So, when I was streaming before, this robot has like the little selfie stick behind it, and it walks around, has commands in the chat and stuff. And this, feeling like overly like I have to explain something, like I don't need to explain anything. Uh, yeah, okay. So but so this lesson plan, okay. This is just webcam input from this the other robot, which is kind of like I really do kind of did actual like robotics research with it. Like if I it's basically a remote control car with like a webcam on it and stuff. So and kind of just do interesting research to like see how it goes and stuff. So this is what I did yesterday, and at the end of that stream was this program that I wrote. So this is an example frame of video. This is like a video frame. This picture was video from that robot, and this is how I process it to like the inputs to like a like this. I process this image into this. So this is there's this idea in computer in machine vision, computer vision algorithms, the and different like approaches that people take to processing images into robot stuff for the robot. So the robot, like this picture process to this picture, that's pretty funny. So so I'm like, well, how does my vision work? And in the way that I look around at the world around me, there seems to be a lot more detail at the center of my vision. There seems to be a good deal more detail in my vision, in the center of my vision, than all the my peripheral vision of the whole thing is more like there's not as much detail. So this image shrunk down to this little pixelated image is the entire image, and this is like the whole peripheral vision and everything. Then the next one over is just half of or a quarter, like a half this way, a half this way, a quarter of the image out of the center. And that's this image, this part of the image. Then another 16th taken out right here. Then I guess it would be a 64th right here. And 64 times 4 would be 256, I guess. right here, and then this is not scaled at all. This is just, and this image is a much smaller image. This is 15 pixels high, 120 pixels wide. There's kind of 6 bins, like 15 by 20, 6 bins of them. And they are convoluted, kind of. There's much more detail towards the center of the image. So this right here is just the center of the image. So when you know, like that, as we go outward from the center, there's just less detail. There's less detail. And so this image is a 640 by 480, 640 by 480, many thousands of pixels, which all have red, green, and blue. And so there's like 3 bytes at least of color data for each pixel. This image is much less data. This is just less data. It's made grayscale. So each pixel is only 1 byte of data, 8 ones and zeros that show how, like, the shading of the pixel. And this total image is only 120 by 15 pixels resolution. And so this is a total of 1,800, just 1,800 pixels. This 640 by 480, if you just, you know, like, I can do that for you. So I type that into our calculator here. 640 times 480 times 3 bytes for red, green, and blue is, that's how many bytes of data. That's a lot, you know. But this, when we've shrunk it down, so 20 times 15 times 1, because it's grayscale, times 6 is only 1,800. That's much less data. And we really, like, when we're doing this stuff, like, these are computers, like, a computer isn't really meant for, I mean, or, well, what a computer is, that's kind of a different lesson plan. But so a CPU is basically like a calculator, and you're just like pressing the buttons on the calculator, like several like gigahertz per second of, like, you know, calculator stuff, and like then, you know, store and recall to like gigabytes worth of storage and like that. And you know, but you know, it definitely, like, it's meant to run software. So like a general purpose computer, like we all are, like in our era of history, that we all have general purpose computers, which are basically a calculator chip with like lots of storage but anyway, so we're like doing, every time we're doing something like this to this is like as if we like typed every fucking thing. Or, oh man, I used the F word. I hope they let me slide. This cross also has the forest creatures on it, you know, like it's embossed with the little forest creatures. So hopefully, well, this is kind of like what I'm explaining to you here. So like, it's a, you know, if we did this by hand, even with like a calculator to help us, we look at each pixel one by one and kind of just have an algorithm that we turn it into this. So this is our algorithm. So this is our camera to input program. So this computer system is like what we're going with to write our stuff. This is Plan 9 front. It's a type of Plan 9 computer operating system, which is, it's meant for, this operating system is meant for networks of computers. I really don't like dealing with computer security. It's like, the worst thing for computer security is everyone is so angry at me. Like, I wish that we could all just get along better. Like, I really, like, I don't feel good about this. Like, when I had my part in things, and I really like try to learn to do better in my life as I keep going, and just like try to get along with people better, which has always been something that I really care about. Try just be a good person, try to get along with others. Really, it's really I don't would like to get along better with others. My computer security is really not fun. It's really like it. I mean, some people are really interested in it. Like if you, I guess, something someone I really look up to when he used the word malicious. Is this with malicious intent? And that's like ruining someone else's day. Like that's not nice to do to someone. So, but anyways, so this is a language called this is well okay. This is the C programming language at like it's like absolute pinnacle, like the mid 1980s, or the research operating system from AT&T, what got disbanded into like there's even an operating system called the Go language, Go F yourself language. The AT&T disbandment and kind of became the baby bells, like, and it settled an antitrust lawsuit which was like pertinent at the time, dollar for dollar, just whatever, a long time ago. Those dollars didn't they were that was a long time ago. So, and it's unfortunate because this is very good. This is the pinnacle of like if you're doing C programming in other operating systems, it's never this nice. Never. Like this is the best it is anywhere. This so like for example, this is U.H is different for different architectures. So this type of computer architecture, this on this particular computer, it's an operating system for networks of computers. So this is I'm sitting at a 64-bit Intel, like AMD, the AMD 64-bit architecture, and this is they're ARM computers, ARM 64-bit ARM computers. Like there's one on the robot here looking at this. There's a cluster of them here on the desktop too, along with the other one. So my PC. Then we include this is draw.h is like for our my dog has epilepsy. I have to like make sure he's okay sometimes. I think he's okay. These images are in the system image format. This AT&T really, their research department, the AT&T research department, the antitrust thing, like they got sued for an antitrust lawsuit, but their own behavior really is what did them in, and they didn't understand that they have to sell products to people. Like they didn't understand that the products have to be like they didn't understand like if it's on a shelf in a store, someone has to want to buy it. So AT&T really just fell apart. This is all still people continued, just like this is just this software, I'm in the year 2026. This software was about like by the mid 1980s they were kind of like, oh no, we're not a company anymore. So but this has a system bitmap image format. This I'm thinking what I'm going to do here. So when I went through this and I thought like, well, I'm going to want these as numbers. And so I converted each pixel to a number to print it out or to send it like these numbers here, like as if someone had typed the numbers. And that was about there. Like if I had 20,000 bytes worth of data, that fit the entire thing. This is 1800 bytes of data with the image header. The image header is another 110 bytes, so it's like when I'm passing this stuff between the different parts of the system, like this is not really what I would call like a picture, but it's data that I can work with, and it's in an image format where I can kind of just see. I can just see it. So I think I will use this system bitmap image format for like just easier diagnostics and stuff. So then then our program. So and this is somewhat common. Like a C programmer would know. A C programmer would kind of be like, "What's this void?" Like that's different on this operating system. Their return codes are not integers. From the main entry point. The main entry point of a program, the main function, is it doesn't return an integer, and they don't return, or they return nothing. But there is a status string, so it's like it doesn't return an integer error code, but there's capacities to like say to print out readable human language. So if there's like a system crash, it'll like have like some readable information for you in English. Would be this system is in English. Well, I mean, yeah, it is. Like see, new, cut, paste. Those are kind of like English words. Xerox is wow. Xerox is an English word. What? Okay, so this and these system memory images of this the system's bitmap image format, and the first one I call I. Our input is going to be one frame at a time. We'll go into this mem image I. So every time it loop, this is our main loop. So I equals the read mem image from the input. 0 is the input. It reads this frame of information. So and this is our like program here. So someone just added this a little while ago. This they added this. It's kind of strange how these things happen. It is really strange how these things happen. So when you'd rather like I don't know, the system, like I don't know, that someone so all right, this like I tried to comment these things so like to help people learn. So these warp structures, someone just added this recently. This is why I'm saying warps, the latest incompatibilities with Plan 9. It's some kind of computer system. This is something someone added recently, which I'm using here. Like this is a brand new, addition to our AT&T software from 1980s. The latest and greatest. So these are matrices for affine an affine transformation of the images. So what that means is affine transformation is scaling. So this is like our next is first next. When we start out, next is 0.5. That's half. So our next is 1/2. The dog needs to stop. Like, buddy, hey, please stop. You just like all right. Do you actually need something, or no, you don't. Stop. Like these warps. This is a matrix for an affine transformation on the image, and if you look this up, you will see some mathematics that will teach you about stuff like that. So what that means is like, it's not just scaling an image. It's like shear transformations. It's like translations. Like if you want to like move the move the image over, or like make it seem farther away, or like if we wanted to make this image look like it was on a wall over here, like if we wanted to make this image look like it was hung on the wall here, you know, like that, there would be a matrix for like how to make this image look like it's hung on the wall right there. And so but what we're doing here, we're just like our matrix for our affine transformation is simpler because we're just scaling to, or just, so we're cropping parts of the image out from the center and then scaling them down to this size and putting them to here, putting here in this our smaller image here. So this is the original size. See, like that, I had zoomed in. So, and that's even, it's even like you can, that's kind of interesting. Like you can kind of actually see when it's yeah, that actually is better to my sensibilities. Like I can sort of see better. Like this is the whole image. This is towards the center, towards the center, towards the center. More detail towards the center. And so then when our main loop reads videos, so we have a video of 1 frame at a time of these. We read 1 frame at a time and just check if it's the right size, and otherwise just stop. We just like, this isn't right. See, this is what I mean too. This fatal call, like our programs don't return an integer. They don't return an integer code, but this returns like, hey, the image resolution isn't right here, like that. And so that'll like tell us like what went wrong there. And then so when we start out, we're going through our, we read 1 frame of video, then we start out like we start out at the center. We start out with the center one. This 20 by 15 little image, to turn it to grayscale, put our 20 by 15 image out of the center. So we start with the height is 15, 20 by 15. X equals y times 4 divided by 3, that's 20 out of 15. Y is 15, x we set to 20. HX and HY, those are half of the width and height. Half of 15 is 7. We're just going to say 7, not 7.5. And that was a problem I started having later, because when I did that scaling, or when I did my affine warp and draw my thing, it was like doing something weird. Like this one had like stuff right along here and here. And I was just like, why is it doing that? And I looked at that and I was like, alright, this is an affine transformation to do nothing. I'm just gonna like take that out and do nothing instead. And so when I did that instead. So this is our else. Like if we're looping through this, the first time that we loop through this, we're gonna skip the affine warp, because like a 1-to-1 scaling should do nothing, and instead of doing nothing, it was putting some weird stuff. So I just skipped that completely. It's just a hunch, but 15 is not divisible by 2. So that's just like a hunch I have about what was going on, but I didn't really look into it. So, and it got filed as an X file. Like there's an episode about that, which is crazy that there probably actually is. They made so many of those. That's such a good show. So I have no idea. I mean, there probably is not. I mean, if there's not an episode about it, like video processing people would know about affine transformations and stuff. So if there's not an episode about affine transformations, like it's something that people would have talked about in the television industry. So, which is not, I mean, like as I explained to you, like this affine transformation stuff is really useful for like if I wanted to make this look like it were a picture hung on the wall right here. That would be something that an affine transformation could be used for. And so like that, they do. So someone just added this affine transformation to the draw stuff for for this operating system, which is really like to just like have C programming. Like the C programming language kind of is standardized as a thing in itself. Like the C programming language just is what it is. Like people who know C would look at this and they would be like, that does not look like C that I've ever looked at, but it's obviously C. And it also looks a C programmer would look at this and they would say, that looks like the C programming language. I know the C programming language. This, like, none of this looks familiar to most C programmers. Like when they would see this, they would be like, what? libc kind of makes sense. So it's C library. Draw, like, what are you talking about? Like, they would just be like, what? And then when they start looking through it more, they would be like, okay, this is extremely good. Like, someone made a very good computer system here meant for C programmers. And it is. AT&T made an extremely good system, like a system meant for C programmers. They were not just like doing weird stuff. Like, they were the people who did this since the 1960s. They really put that much effort into like doing things like very well for C programmers. And then when it was on the shelf in a store, most people were like, I'm gonna buy Windows, you guys. I'm sorry, I'm gonna buy Windows. Especially a copy of Windows on the shelf was like $100. When you just bought your PC, like, there was a copy of Windows right on the shelf, says PC compatible right on the shelf. $100. That's $100. That's a little steeper back in 1990. That's a steeper price. $100 in 1990. Inflation and stuff. And then this operating system, AT&T was like, we don't know what you mean. Like, we've never had competition in a business sense. And so we'll sell this to you for $20,000, and it doesn't work on a computer. Well, this is for C programmers, so you can have this for $20,000. But if you don't know how to program in C, like, you're just like, why do you have a computer? Like, what do you mean? Like, that's not what a computer is. Like, what is the DOS? What's a computer? Like, you're saying a personal computer? Like, for a person, like, not a C programmer. Like, what are you talking about? What? Like, and AT&T was like, what? No one's buying it. It's like, it only costs $20,000. Like, compared to what we were selling people, like, we're trying to give people a deal here. $20,000 for this. Like, it's all together in one little package. And they just like, people are like, no, like, I'm not gonna buy that. Like, this is $100 for Windows, like, which is easy. Like, you click on stuff and it does stuff. And AT&T's like, yeah, like, it show you this. Look, if you click on stuff, it does stuff. Like, it does. If you click on stuff, it does stuff. Don't you see? And people are just like, look, we just have no idea. Like, this. People are like, I'm not gonna buy this for $20,000. I'm sorry. Like, and AT&T was like, all right, we're not even a company anymore. We're a bunch of little companies. Like, we're not even doing this. We're done. And the Department of Justice was like, thank God people are not talking about Nixon as much right now. And it was good. Like, things were kind of much better. Like, things were a lot better for a little while. Like, measurably. Things were measurably much, like, empirical evidence, things were better for a while. And so, that's kind of horrifying, but anyways, so, and then also in the 90s, this show, The X-Files, like, how are there that many people in the world who are just like, I was a person in the 90s who would, like, watch The X-Files and just, like, I was like, wow, that's weird. A weird show about ghost stories or something. Like, I don't believe in any of that. And there's, like, in the 1990s, this demographic of, like, millions of people, this never had to like, you know, decapitate a chicken and like throw its head over the roof or something, I would be horrified. This cross in particular is embossed with the cutest little forest creatures and stuff like that. But so, horrifying, truly, truly. So, but this, what this? Okay, let me think what I'm. Okay, so yeah, but you see, this program just takes these system bitmap image formats as like you know, frames in a video and turns them into these. So and this was I was doing this on the research robot thing. So when I was doing this yesterday on the research robot thing, and my stream had to be taken down. There was something inappropriate, or I'm not sure what happened. So, but this is a different computer. So I'm not sure. Trying to think how I might be able to do this here. So, what I'm gonna try doing here. Let's see. So. Uh, what I'm trying to think here. So I'm trying to just use my desktop computer to get to take this picture. Here's my webcam. So first, let's try this first. This is not really going to work very well, but so let's see here. Hello. Yeah, it's not working that good. Okay. That ain't working that good. Okay. Oh no! Okay. So now let's try to do this in our robot image format thing here. So this. What I'm doing here, I'm trying to encode my webcam on the desktop computer and just bring it into the AT&T land. So this, and let's see. No, wait. After I got this is where I'm going to use my program that we did here. So our camera to input program. Then we'll think we're going to resample it to make it a bigger make it bigger. So let's see. When we were looking at that, I said something about that, like it was kind of more. We were more able to tell like what we were looking at. Probably this, like we've scaled maybe in our like 4 times as big from the little picture, and then we're gonna play this video, and it's gonna kind of glitch out and stuff. So let's see. No, that didn't work. Okay, let's see. Just close out of that. I don't know what happened there. We don't know what happened, and we're blaming like major world governments, like the you know, like getting paranoid again. We start devoluting into you know, people who sat at the computer too much. So all right. Well, we're doing better. We're doing a little better now. So let's see. I think this is what I did. I think this is. Let me see here. Is this a program? Try to check if this is a program. It is. So let's see. Let's scale it up to like. I guess it doesn't have to be. Well, it should be like, let's say, twice as big. Okay. And then send it to our vid program. And there. So now you see this is that is kind of what a webcam video. This is like I put my hand in front of it. I don't know. That's like it. You can't even see. But to the robot, that's like the robot's like, oh yeah, that's my perception of reality. Like this is how I see reality and stuff. So and that'll be like how the robot, like our initial image processing is to process the webcam video into something like this. And the reason, so again, the reason that I did all this and why I think that it should be processed this way is that it just like as I look around at the world around me, when I focus on something in my vision, like that, I just have more detail at the center of my vision and then less to the periphery of my vision. And that my vision is, not the same as a webcam. And if I wanted to keep going with this even, I could put like a fisheye lens over the webcam or something. Like that would be kind of cool and probably kind of useful and stuff. Like might do that eventually. That might be kind of useful. But this is our initial, like, what we started with. I showed you, we're kind of processing the image ahead of time to just so that it'll like work well for what we're doing. And so what we're doing is some kind of robotic. The overall idea here is kind of a remote control car, and like it's a remote control car, and I'm going to drive it around with this gamepad, and it'll kind of copy the behaviors. So when I drive it a certain way, it'll like learn to drive like that. Like a behavioral, like the behavior of the robot initially is like that. It'll like the behavior of a remote control car, if it's turned off, is to just sit there and not do anything. Then if it's turned on and someone's driving it around, that is the defined behavior of the remote control car, is the person driving around. And then it'll have like a webcam and sensors on it and try to drive itself around that as I'm driving it around, and learn to copy my behaviors of how I'm driving it. And that's the idea here. So, and that's what we got so far. And so again, I apologize that when my live stream the other day, like I had it on for like a whole day, so I don't know if like the dog did something gross or like, like probably blame the dog. Like the dog, like he doesn't mind that much, and just like whatever was inappropriate and the stream had to be taken down, I do apologize, and I will try to do better in the future. And if you can subscribe to my channel, I would like to get to 1,000 subscribers. And if I had 1,000 subscribers to my channel, it would be, to me, 1,000 subscribers to my channel would be like a dream come true, just truly. So thank you.